I have just make a layout for delay cell and make a layout as well make a full system with the on chip and off chip component, but the output is wrong with the signal is wrong, so I need to figure out problem at the end of week. And in the layout I make the firstly I need to make a layout for delay block, and then I make a layout for the full width control. This in the full width control we have the layout for the notch and or and mush and everything without the delay block. So after making a delay block layout, so I can combine them to a full system layout. And because my layout for delay blocks very bigger, so I need to optimize them more smaller, and then I will combine them later.
So other layout for NAND gate and other gate you have not complete, right? You have not started, right? Have not started yet.
Yes, because I have seen it in the library, so I don't make it.
But in library is 5 volt,
Oh,
right?
okay, okay,
In library 5 volt. In your case 2 volt. You have to make your own layout, right?
okay. I will make it at the weekend.
Yeah. You have to lay out again because the standard is 5 volt. Are you using 2 volt or 5 volt in here?
I using 2 volt MOSFET.
Yeah, so if you run DRC LVS layout versus schematic, it will be wrong if you use standard cell because
Yeah,
standard cell is 5 volt. I told
yeah.
you, right? You have to
Okay.
lay out by your own. I
Yes.
don't have 2 volt standard cell, so yeah.
Okay. I also I don't have the caliph to check the rule in the layout. So in the weekend I will ask other left Miss Lan to check to train it.
So next week, let's try to finish power with control layout. Actually,
Okay.
rather than even don't start layout yet. So your homework next week is finish layout. Okay.
Okay. Okay.
That all?
Okay.
Right.
That's on my plan. Let's start.
Okay, my screen. Actually, I don't have any presentation today as like I just designed the wait, excuse me. Yeah, so I don't have any presentation today as I just like made the whole system schematic and designed the parameters, but there were some problems. The Cadence actually crashed twice while simulating, and it takes a lot of time. So like it just could like again the parameters.
Why is plus? Why when you run the simulation?
Yeah, it crashed twice today.
You cannot run to 100% simulation.
Not often. And like once I ran, there was like the P star value was not shown. So I changed the equation, but then like the cadence crashed for some reason. Oh, by the way, I actually like noticed that if there is a direct control, like this one, right? This one is the P-rect in the control circuit.
Yes.
So there should be a P store control as well, right? Because like there is V store in the control circuit as well. For example, here, here, and then in the delay cell, then in the comparator, there is V store as well. So there should be a P store control as well, right?
No, actually, we don't care P store control, but we care the output power. Output power means the only power remaining to be harvested, right?
Oh,
Because
I see.
will be the power lost. We don't
Oh,
care.
I see. So, but this is a power. This power is being spent, right? So this should be in the efficiency equation. This should be here, right?
What do you mean?
I mean, like in the efficiency equation, like this is a power that is being like spent, right?
It is just power loss.
Yeah, so this should be in the denominator.
So let me share screen.
Okay. And I will make layout next week.
Okay. Wait, so we have buck converter, right?
Mhm.
We have V store here. So V store will connect here for control, right? Isn't it?
Okay.
So we have VREC input the converter, right? Its energy is we have via flip. We have PJT. So we harvest energy from PJT and store in capacitor, right?
Yes.
And capacitor is just the middle. It's just how energy, and then we harvest energy. Some part of energy in VREC is used for control, right? Okay.
Okay.
So we have in here is in input of buck converter. Let's go is P VREF in, and control for buck converter we call VREF control, right? So total buck converter input power P in buck should be this plus this, right? 1,
Yes.
2, right? This is the input power.
Okay.
And output power will be PV store. Is energy is harvested and delivered to storage output, and a part of energy is used for control circuit, right?
Yes.
So it will be PV store control. So the output we consider P out, but is just PV store. It is energy loss, right?
Yes.
And some energy loss are the P loss is in conducting from inductor or MOSFET and other thing will be other P loss, right?
Okay.
So total I call is P loss. Here P loss, but total P loss equal P loss but plus P with store control, right? Isn't it?
Okay.
So P in power is balance, right? P in will equal P out. Is will equal this PV store equal 3 and PV store control equal is 4 and P loss buck will be 5. It will be 1 plus 2 will be equal 3 plus 4 plus 5, right? Total input power should be equal to total output power. And efficiency is only PV store, right? The harvested power, isn't it? Only
Yes.
PV store over P in what? So in simulation, the efficiency will be the input power go to here, go to this DC voltage, right?
Yes.
Over the power go to the here P in feedback in is the power input power go to the PMOS. Right? Here P one power one is power go to PMOS plus control in VRAM. You got it?
Okay. Bro, I have a question.
It's only 3 1 over 1 plus 2. 4 and 5 is just lost. Okay?
Okay, I got it. But I have a question.
Yes.
Can you open the IDE?
What?
IDE for running? Yes. No, IDE for running.
I will open Ryan library first.
Okay. Okay.
Ryan, did you get it? Got it?
Yeah, got it.
What do you want to ask?
Okay. Bro, I have question about the reference from the 1 to 3. Why we use the 5 voltage? On why should we use the volt power from the V solid to power the V reference from the 0 to 3 instead of using the external voltage 5 volt?
Here?
No, IDE.
Where?
IDE that you okay. So why should we use the V reference 0 to 3 from the restore 1.8 instead of using the external voltage in the 5 voltage?
Actually, in here 2 volt mode fast, so it should be 2 volt. 5 volt is still work, right?
Oh, so so we need to use external voltage to power the object of reference 0 to 3.
Yeah, because in here reference does not consume power, consume very
Oh,
little power. So
okay.
this gate actually for power MOSFET is big current flow, right? In this
Okay.
keyboard and NMOS, we deliver milliampere current through inductor. So milliampere current through this PMOS and NMOS. So
Yes.
the size of this MOSFET is also big. So we need
Oh, okay.
more power to control this gate and this gate. But for this, we use very small MOSFET. So power consumed here is very small, so we can be omitted.
Okay.
Almost zero compared to the other circuits. So we can use external reference voltage.
Okay. Okay.
Okay.
Okay. I got it. Okay.
Yeah.
Initially, I plan to use the voltage from the on-chip component, and I push the reference voltage on-chip component.
Yeah,
It's okay.
you can put is ground and V store, right? You can put V
Okay.
store here, but you can check efficiency will not change.
Okay.
Only
Okay.
small
Okay.
power consumed here. Okay.
Okay. Yes. Yes.
Do you have any other question?
No.
Okay. So next week let's try to finish layout. We still have 8 minutes left, so let me have something to. So next meeting. Today meeting is so you guys almost draw full system. So you should check efficiency again, right? You have not checked it,
Okay.
and
Okay.
try to finish power control.
Okay.
And next meeting is 11. So let me check Ryan. Let me try to check Ryan simulation.
This one.
This one, right?
Yeah. Yeah.
Are you still open it?
Oh, okay. Let me close it.
I will copy to my library.
Okay, I closed it.
You run until here and it's crashed, right?
Mhm.
10 to 50. So let's check to 15. to VREF is 14. In here, Y 25, but VREF is only
No. That n is like delay cell. That n is completely different.
huh?
That n is like not the n. It's m actually. M is equal to 8.
Here, you
Yeah,
change
that n is delay cell. That's delay cell.
you
property.
change N and M in here.
Yeah.
Okay. I think you should not change here. You should be N and here M. It should be better to avoid mistake, right?
Yeah, but I already made the delay cell with n and did all the simulation. It would be tough. I mean, I had to change in many places, so I just changed the other way.
Where you put N in where?
No, in the delay cell. Delay cell.
Delay
You go to
cell.
the pulse width control.
Here.
Yeah. Go to the delay cell. Here, L is equal to n times 500.
Actually, in the layout, you cannot put N and M for MOSFET. In the layout, you have to make each real number. Remember
That is a
Yeah.
mistake that I missed this morning.
Yeah.
Oh,
So,
then I will
Yeah.
just 5 because n is equal to 20.
yeah, so later you should, in here should be 25
Times
multiplied
500.
500. Yeah.
Okay.
So you should put the real number here to do layout,
Okay.
right? So efficiency should be P store, right? P store. Or PREF. P store. Y is P store over PREF
Plus period control.
plus PREF. So yes. It's look in my case 772 maybe. Let's try to run up to 100 milliseconds. Yeah, right. In my case, in your case now is 8, right? N is 8, so it's my different, right?
Yeah, it's different.
So VREF now here you different in my case, so